Alright, welcome back to my channel, and today we're going to look into water potential. So, water potential. What is water potential? Now, think of it like an ability of water to move from one place to another. So, if water is able to move from one place to another, this is known as water potential. So, just write it down. It is the ability of water to move from one place to another. This is known as water potential. Now we denote it with the symbol psi, and is actually measured in Pascal or megapascal. Now, when you look at these two glasses, this is a glass of water with pure water. It's having no mixture in it. Nothing is mixed. And when you look at this one, it is having some red dots. I've denoted that as sugar. And sugar is a solute. Anything which is able to dissolve in water is known as solute. So this is pure water with no mixture. Nothing is mixed here. Nothing is mixed here. And here, sugar is mixed. Now, why this is important? You need to think of it like when you have pure water, the water is able to move more. Nothing is holding it down, or nothing is binding it. Now, when you look at the other glass with some solute or sugar in it, you can think of it like this image, that the solute has got hold of the water or H2O molecule, and it's telling it you're not gonna go anywhere. So it is less likely to move anywhere. So that means when you have pure water, water is able to move more, but when you have solute mixed in it, it is able to move less. Now, this thing is quite interesting because when you think of it, there is high number of solute in water, just like this one where the glass is actually mixed with a lot of sugar. So when you have high amount of solute in a water, then you have more amount of water that is occupied. That means it's able to move less. And this means that you're going to have less, or you can say you're going to have a solute potential which is negative. That means that it is going to take away the potential of water to not able to move. That is the reason the water potential for solute will be negative. It won't be able to move. So always remember this. This is quite important. When there is high solute mixed in the water, that means high number of H2O molecules are occupied. That means the solute potential will be negative. Why I'm saying it's negative? Because water is not able to move as freely. Not able to move as freely as it wants to. That is the reason the water solute potential is always negative. It makes the water to move less. Now, when you think of pressure, think of it like when you're squeezing a ball of water, you're putting pressure from beneath it, so the water is moving up. That means if you squeeze a balloon with water, the water is moving in an upward direction, just like this. That means water, when you put pressure, water can move, right? That means if water is able to move, it is bringing something positive. So the pressure potential will always be positive because it can make the water move from one place to another. Now, when we think about the equation of what exactly is water potential, you can say that water potential is the potential of solutes. That means how many of them are mixed in water. that can impact the ability of water to move. So you can think of it like water potential is actually dependent on the number of solutes that is present in the water. So water potential is equals to potential of solute plus the potential of the pressure, or the pressure potential. That means if you apply pressure, the water is able to move, and this will be positive. By the way, the solute potential is negative. So this will be much more positive. That means pressure can impact water as well. It can, if you put pressure, it can tell the water to move. So when you think of it, this is an important formula, and you can say water potential is directly is equals to the number of solutes present in a water, water or mixed in water, or the pressure applied to water. So remember that. Now, when you look at this diagram, you can think of it like where it's quite interesting, and it shows a really fun experiment. So right over here, you are having a U-shaped tube. You can think of it like that, and it's having a membrane here. Now, what is a membrane? Basically, it's allowing the water to move, but it's going to stop any solute from coming here. So there is no solute. Remember, solute is just like salt, sugar. It's not going to let the solute move from, let's say this is right and this is left. It's not going to allow the solutes to go from right to left. So this is pure water. This is pure water, and this is water mixed with solute. Now, interestingly, what is happening, you can see that the water level here is lower than the water level over here. That means water is moving towards this direction. Now, why is that? It is because there's a lot of solutes over here and there's no solute over here. And when you think of it, just for example, let's take sugar. Like I told you before, sugar will be surrounded by a lot of water. It's attracting water. It's just like holding hands with water. It's not going to let it go. So water is going to be sucked up over there to the solute. So that is the reason the left side is having a decreased level of water and the right side is having increasing water because it's having solute. Now, why this diagram is important? When you look at a real like concept, you can think of it like plants. Plants are actually having so many solutes over here. Like it's having a number of solutes, like it's having salt, it's having sugar inside of it. And that is the reason it's able to suck water from the root right to the tip of it. Because water is having efficiency, or you can say attraction towards the solute, and it's going to go over there and hold hands with them. So that means when you look at the diagram, sorry about that. When you look at the diagram over here, the number of solutes that are here are really high. Just like this over here in plant. The plant is having a lot of solutes up there. And that is the reason the water is moving in a gradient. The water is moving from a low gradient. What do you mean by low gradient? Let me clear this up for you. Yeah, the water is moving from a low gradient. Low gradient is when there is less number of solutes. In this case, there's no solutes over here. Less number of solutes. Okay, let's call this A side and this is B side. So the water is moving from low concentration to high concentration. High concentration here means there are more number of solutes. So that is the potential of water, the ability of water to move from low concentration to high concentration. This is called concentration gradient. So when you think of it on the real life aspect, the number of solutes present at the top is high and in the soil it's low. That is the reason the water is able to move from low concentration right to the tip of the plant. So this is a real life concept that you need to think of. Now, why this is happening? What exactly is happening over here? All right, so when you think of, let's say sodium is like a solute, all right? So when I say solute, that means it is having some kind of partial. Before that, I'm going to say a solute is a polar molecule. What do you mean by polar molecule? Polar molecule is nothing, but they are actually hydrophilic. Now, what do you mean by hydrophilic? Let me change of pens here because I think this one is a mess. All right. So I'm just gonna get rid of this real quick. Okay. So these are hydrophilic. These are hydrophilic, and philic means lover. So all the solutes are water lovers, and they are going to attract the water molecule. And water molecule is actually bent. It's not straight. It's like a bent molecule, and it's going to go towards the solute. And again, think of it like holding hands. They're going to hold hands really tightly, and they're going to hold hand in a circular manner. And they are going to create, just like this. Look at this one. There's Na or sodium in between, and the water molecule is actually like forming a shell around. And this shell has a name on it. It's called the, oh, again, the wrong pen. Hold on, just, yeah. This is called the hydration shell that is going to be around the Na molecule, that is the solute. Remember, solute is something that is going to mix in the water really well. And the reason it's doing that is because of this hydration shell that is formed by the water. And it's going to help it dissolve into water really nicely. So that is the reason the solutes attract the water molecules, and it's going straight up that plant really nicely. So, and why it's going that up, I forgot to tell you. Sorry. It's having some kind of negative and partial positive charge, which attract these molecules together, and they form a hydration shell around, and that's how they are having better ability to dissolve in water. So when you think of it with the concept that I just told you, it's pretty simple, that plants are having solutes high up over here. They're having solutes high up here, and they're attracting these water molecules up there, and that's how they transport water. And this is actually a really important concept in transportation of plant, which you need to really remember. So I hope I made that easy for you. Now, once the water is up there, in the plant, it is actually forming a pressure on the wall of the plant cell. And like you can see, there's plant cell here and there's arrows here because there is water inside the cell, which is causing a pressure, and there is water coming from outside as well, which is also causing a pressure on the cell wall. And this is actually really important when you think of transportation of water from one cell to the other. How are they doing that, especially when you want to go up against the gravitation force? So this is a really important concept that you need to remember about water potential. Water potential is first, it's like the solutes are affecting the water to move from one place to another. And another thing, it is causing turgor pressure. The pressure that is put by the water on the walls is known as turgor pressure. And these two things are most important in transportation of plants, which is an important chapter in your biology examination. Now, let's take an example of a very simple calculation. Before that, I'm just gonna roughly tell you about the definition of water potential. So water potential is actually the free energy of water to move around. That will be per unit volume. How much the water is able to move, that is the water potential. And it actually determines the direction of water. It's going to determine the direction of water. That is, water potential is going to, first, it is the free energy of water molecules, where it's going to go. And the second thing is it's going to determine the direction of water. And third, you need to remember, it moves from high concentration to a low concentration gradient. Now, again, I'm just going to take a really simple example for you to understand. Let me just get over there. So we are going to do a very simple problem. So, for example, in a plant cell, so let's say you have a plant cell. In there, you're having a solute potential of 0.7 megapascal and a pressure potential of 0.5 megapascal. So what is the total water potential? Now, I hope you remember the formula, which was really easy. It was the water potential is equal to the number, oh, sorry, the solid potential plus the pressure potential. So we will just substitute the numbers here. So the solid potential is 0.7. Hold on. I'm just going to write it over here. So the solid potential, oops, I feel like my pen has died. Anyway, so the solid potential is 0.7 and the pressure potential is 0.5. We're just going to add that, and it will be, this was actually negative because we forgot, I told you before that the solid potential will be negative and the water potential will be positive. So I'm just going to put a negative sign over here. And for some reason, my pen is not working. Anyway, so just remember there is a negative sign in front of the 0.7 and there's a positive sign in 0.5. So my negative plus positive is plus minus is minus, so we're going to subtract it, and the answer will be 0.2, but we will put the sign of the bigger number that will be minus. So the answer will be minus 0.2 megapascal. So thank you for joining me, and if you want to join my biology classes, fill out the Google form in the description box below and I will get back to you. Happy learning.